I'm Snow. I'm Paola. I'm Sandy.
So our objectives were to learn how to use an absorption spectrometer, to use variable dilutions to discover the concentration of stock in the diluent, and to learn how to make a calibration curve in Excel. And then our goals were to use absorption spectrometry and use absorption wavelengths to identify food dyes in a given substance, and then quantify how much of each food dye was in a given substance.
So for our unknown substance, this was what our spectrograph was. Our first peak was at 425 nanometers, and that was our yellow number 5 that was in it. And our second peak was at 628 nanometers, and that was the blue number 1.
And then this was the results that we got for our concentration. So we just had the volume of stock, the volume of diluent, and the volume of dilution, and we basically just did them equally. We do the concentration.
Concentration, what's on our next slide? Do you want to switch it? So for blue, this was our example, we had the volume of the concentration, which was CD, which is equal to the volume of the stock multiplied by our CS was the concentration of the stock, so for our blue. And then VS was the volume of the stock, and we multiplied that by the volume of dilution to get the concentration.
And then here were calibration curves that we made by comparing the absorbances with the concentrations. And so you can see some of the dots on yellow number 5 are kind of off. I think that's just because we had a little bit of issues with the volume when we were actually putting the liquid in the cuvettes. But we'll talk about that more later. And then we have our slips on here. For blue, it was 587.585, and then for yellow, it was 21,946.
So for food dye results, we had found that the mass per 500 milliliters for both of them were kind of far apart. There was 1.84 times 10 to the power of negative 9 and 6.93 times 10 to the power of negative 10. We found it by taking the slope, A times slope, and we got just the regular concentration of the dye. Then we took that and we converted it from moles over L to grams over moles using the conversion formula. And then we did that for both yellow number 5 and blue number 1.
Okay, for true P, we found that our unknown substance had yellow dye number 5, which was 425 nanometers. And then we also found blue dye number 1, which was 630 nanometers.
This was our table for our parallel dilution sets, and we took the concentration of yellow number 5 in this table, and we multiplied the volume of the stock by the full volume of the dilution, and then we multiplied that by the volume of yellow number 5 stock. And then this is for blue number 1, and we went through the same process. That's how we got the concentrations. These are our calibration curves for yellow number 5. The dots were also a bit off. For blue dye number 1, it was a lot more linear, and we got exactly 1 for our story. Yeah, these are our results. For our molar absorptivity, we got 2.61 times 10 to the power 4, and then for the mass of die per 500 milliliters, we got 6.12 milliliters. And this is the math as to how we got those values. For the last table, we took, to get the concentration, we got the absorbance from the calibration curve, and we divided that, the absorbance, and we divided that by the slope that we got from the calibration curve, and that's, how we got the concentration. And then for the mass of dye, we just took the concentration, well, in this example, the concentration of blue dye number 1, and then we multiplied that by the 500 milliliters, and then multiplied that by the molar mass, and that's how we got the mass.
Okay, for group A, group B results, the difference, I'd say the wavelength and maximal absorbance were pretty similar. Same with the absorbance. The slope was where we found it was slightly different. There was differences, like they were swapped for both of them. The molar absorptivity, they were also pretty different from each other. The curve R2 was actually pretty similar for both of them. And then the concentration of dye was also pretty, the yellow dye number 5 was similar, but the blue dye number 1 was pretty different. And then the mass was also pretty different for both. And then recommendations.
For our group, some of our solutions seem more full in the cuvettes, which may have been a problem with the micropipette, and we could just redo those samples to make sure that they were correct, and that might have been the reason for some of the data being correct.
For us, we didn't include the blank, so the water, which is the water, so